All right, well, good evening, everybody. Welcome, Zoom folks, and welcome Chester and House Knoll folks here. We're very excited to have you here. Thank you all for joining us. We're having an event a little different than what we've done this semester, and that we have a live in-person speaker here, someone who's very familiar to us. We're big fans of Professor Jonathan Lunine. We're really excited to have him. Faith and science discussions are at the center of a lot of what Chester and House does. Historically, we basically started out as really kind of majoring in those topics. They're always there's a wide scope of these discussions, but anybody who's interested, and I think every thoughtful Christian should have something like some awareness of what's going on in some key areas. The most important ones in general are, the emergence, the origins questions. And so there's kind of three of those that really dominate the conversation. But first is the emergence of the mind. Where does consciousness emerge? The second is the emergence, keep going backwards. Where's the emergence of life itself, as in biological life? How does that emerge? And then probably the kind of most fundamental one is cosmogenesis. Where does the actual universe as a whole emerge? All three of these impinge in territory of contemporary empirical sciences. And it's not always obvious how to take the deliverance of these sciences and say the theological commitments we may have as Christians, or those who are not Christians, wondering how Christians kind of engage in this. Those are complicated and interesting questions, and they require often the guidance of people who know both the theology and the science. And because it's so hard to just learn one of those, it is extremely rare to find people who know both of those very well. So when you find one, hang on to them. That's what we have, Jonathan. So we're really glad that we can have you here. For those of you that know, thank you for joining us. We have tonight, we're going to have a Q&A time around halfway through. We'll switch to Q&A where those of you here and online, you can ask questions, just put them in Slido. For those of you here, there's a QR code. I'd ask you to get out your phone right now and put this thing on so you can actually, as you think of the question, throw it in there, because don't wait. If you wait, you forget the question. The other thing is, keep that on because other people's questions will be in there, and we want you to weigh in on whose questions should be asked. You can upvote questions that are of interest. So even if you don't have a question yourself, see which one do I want to be asked first? And that goes also for those of you on Zoom. We have it, it's in the chat there. You can put that in and use the Slido. If you put your name in, if you're in the room, I'll be happy to have you just ask it directly. If you want to ask it anonymously, which often we've had to do in prior conversations of controversial territory, and I'm guessing this isn't one of those, but you never know. You could still do that. Yeah, right. So you just leave your name off, and then it's going to be something that we'll read off over here. But otherwise, we'd love for you to ask it. Those of you in the Zoom, unfortunately, I'm going to have to ask you to just keep it on in Slido, and I'll read your question out, because today we're not set up with the AV to be able to have you piped into the whole room. Now I want to introduce our speaker. So here's the long, impressive list of credentials, shortened up in the very abbreviated version. Very, very short version. Okay, so Professor Lunine is, am I pronounced your name right?
You did.
I mean, for years I've been saying it. Okay, I hope so. So tell me, you should correct the rest of this. Is it a planetary scientist and astrophysicist? So far,
Yes,
so good.
keep going.
The David C. Duncan Professor of Astronomy.
No, David C. Duncan Professor in the physical sciences.
Oh, this complicated.
Yeah, sorry, it's the whole.
In the physical
Cornell
sciences,
thing. Yeah, right.
and then chair of the Department of Astronomy.
Yes,
Yes.
yes.
So
Great.
in Byzantine structure of Cornell's departments, you figure that out.
Right.
His own work focuses on planetary formation, evolution, habitability. Could I just say extraterrestrial life and its kind of related issues?
That's sort of the end.
Yeah, the end goal.
All
Yeah,
those
but
things.
okay.
Yeah, that's right.
Now, one interesting thing is Professor Lunine has worked on both the theoretical side of his field as well as extensive kind of research leadership on the a number of very high-profile space exploration missions. So the Cassini mission to Saturn, which is concluded, you were telling me, the Juno mission to Jupiter with NASA, that's orbiting as we speak and still going on.
Yeah.
I think in the future, a couple of years from now, the Europa Clipper mission.
Yep, 2024.
2024, everybody's waiting. And you were also on the science team of the James Webb Telescope, one of the most important projects we have running. You're a visiting distinguished scientist at NASA's JPL, the Jet Propulsion Laboratory.
Right.
Okay, and member of the National Academy of Sciences, in good standing.
So as far as I
Major
know,
dues. Yes,
as of this morning.
yes, okay. Now, that's the usual stuff, but let me say something of special interest to our audience here. If I can call you Jonathan, as we normally would speak, and Jonathan was born and raised in a Jewish household and was an adult convert to Christianity, becoming Catholic, and becoming as well one of the founders of the Society of Catholic Science. He was the vice president, and Billy, I'll ask you to just be able to check on the news there. And then he's also spoken, written, and taught extensively on cosmology and faith and science kind of research issues. He's the faculty advisor here. Well, before I get into that, according to Wikipedia, you have 380 authored research papers. But then I learned that's out of date.
Or co-authored.
Co-authored, yes. And now it's up to
394.
94.
Right.
So
who's counting?
A somewhat active, yeah. So apparently you're pretty busy. I'm guessing at that rate, by the time tonight's done, before the lights out, you will have zipped up another one, 396. There's a party scheduled for 400.
Yes.
That's coming up. But if that weren't enough, he is one of the most active faculty we know of involved with students and other kinds of faith and science research stuff. So he is the faculty advisor to the Thomistic Institute here at Cornell, a wonderful group which we partner with all the time, and they do an amazing amount of really good work, and you're a driving force behind that. Also involved with a brand new initiative that's just kind of being real, it's public, right? We can say.
Yeah, it is public.
Okay, so Collis, it's a new Catholic kind of faith and scholarship center here at Cornell, which Chester House is also excited to partner with. We'll be starting, and Jonathan, again, is the driving force behind that. And I think one of the most striking things about Jonathan is that a time when most scientists are basically siloed into heavily technical disciplinary work. They're usually not that interested in the history of science, let alone theology and philosophy. Jonathan is one of the very few scientists I've ever met who's extremely active in all of these and well-versed, not just in his own discipline, but in these very different perspectives, which takes often many years to kind of internalize and absorb. And so it makes him a very rare and unique guide to this terrain that we're going to talk about tonight. So we're really lucky to have you. Thank you for joining us.
Great to be here.
Give us a hand. So to start out our topic for tonight, in 2018, the International Astronomical Union, it's about, was it 10,000 plus scientists in this, had a vote. They voted to rename the Hubble Law the Hubble Lumetra Law.
Yes,
is that right?
That's right.
And that was a decision which involved, giving credit to someone who was basically unfairly forgotten in this history of cosmology. And so if you were like me, you asked George who, because I did not know who this was. So why don't I ask you, first of all, how do we pronounce his name? Because I'm not sure I'll ever get it right. And second, give us a little introduction to George Lumetra.
Okay, great. Well, thanks, Rebecca. I'm really glad to be here. So I'm not a francophone, but the best that I can do with his name is LeMaitre. LeMaitre. And if we have any francophones here, they're welcome to adjust that. I'm going to, because it's exhausting for me, just use the standard American mispronunciation, LeMaitre.
LeMaitre.
That's okay, yeah.
Okay.
And there he is behind us, look at that. So LeMaitre was a really remarkable man. He was a remarkable scientist, a remarkable figure in the Catholic Church. He was a Catholic priest. He was a Monsignor. He was named prelate of the papal household in the early 60s. He was the president of the newly formed Pontifical Academy of Sciences in the mid-20th century, which was intended to bring both religious and non-religious scientists who had accomplished great things together in much the way that national academies are. That was all on his church side. On his science side, he revolutionized cosmology, which is the study of essentially the structure and the origin of the universe. And yet he was kind of an unsung hero. In fact, his biography has really been misunderstood by a lot of people. One person who's a well-known physicist and a Catholic characterized him as a sort of a Walter Mitty type who was just in the right place at the right time. So he's just, for whatever reason, not really well understood. So what did he do? He was one of the early pioneers to solve the equation, the Einstein field equations of general relativity. So Einstein published this theory in 1917, 1918. There's a series of equations that essentially describe the relationship between the geometry of space and the effect of matter and energy on the curvature of that space. And your job then is to pick out a geometry of the universe, a set of laws about how you measure lengths in space and time that will satisfy those field equations. And he was the first to really do that in a way that agreed with the data. Others, including Einstein, had of course had their solutions. Einstein's was a static universe. He believed the universe was eternal and unchanging. There was little evidence to the contrary of that when Einstein formulated his model. And so to prevent everything from sort of collapsing in on itself, because as we know, matter curves space, and so that tends to cause space to pull in, Einstein put this very famous fudge factor into his equations called the cosmological constant that pushed everything back out again. So LeMaitre and a few others provided solutions that didn't require that cosmological constant. But LeMaitre's solution, he actually derived in a way that would be consistent with the data that were starting to come out at the time, which was in the late 1920s, that showed not only that the universe was expanding, but it was expanding in such a way that the recessional speed of a galaxy from us, we're the observers, is just proportional to the distance of the galaxy. That's the Hubble-Lumetra law. It came naturally out of the solution to Einstein's field equation that he formulated. He was not recognized for that because he published that paper, being born and raised in Belgium. He published that paper in French in a Belgian journal, the Annals of the Scientific Society of Brussels. And at the time, there's no internet, so unless you were a subscriber or your library was a subscriber to the journal, you would not have known about this. Many people didn't. And Hubble didn't know about it when he published his data, which corroborated that model. So it would be decades before, in fact, it would be effectively 100 years before Lumetra would be recognized with this vote by the IAU, more strictly speaking, 90 years. But he did more than that. In 1930-31, he published a famous letter in Nature in which he proposed that the universe had a fixed beginning, that there was a point in time and space at which our universe began to expand from what he called the primeval atom and what would later be called the Big Bang. He actually came up with this idea thinking about entropy and quantum mechanics, which was quite something for people who did general relativity at the time to think about quantum mechanics. That wasn't very usual. He was later on in the 1930s, he came up with the idea that Einstein's cosmological constant might not be a fudge factor, but might actually be a property of space. The space itself, the fabric of space, carries with it a kind of an energy, a vacuum energy that would cause it to expand naturally. And he published that in the 1930s, and he's credited now with having essentially presaged the idea of what we call dark energy, which is driving the expansion of the universe. And his name comes up everywhere. My colleague, Saul Tucholsky, who does general relativity, about 3 years ago or 2 years ago, was explaining the significance of the Nobel Prize that was given at the time in physics, having to do with black holes. And he brought up Lemaitre's name. We all think of the person who figured out the event horizon of a black hole, the point at which light cannot escape, as Karl Schwarzschild. It's called the Schwarzschild radius. But Schwarzschild did a mathematical solution that actually created an infinity at what we now call his Schwarzschild radius. He had an infinity at the center, a singularity there, and he had a singularity at this horizon. And it was actually LeMaitre and his MIT PhD thesis that did a coordinate transformation and made the Schwarzschild radius a finite radius. And he was not really credited with that until many decades later. So in a period from the 1920s up until the beginning of World War II, he made just a remarkable series of mathematical discoveries and insights and papers. And in contrast to my list, which is mostly because I work on spacecraft missions, so we get lots of papers written by 50 people. His papers are just by Georges LeMaitre, period.
And they're very short. The
And
1931
some are
paper,
short, some are that. So that one was very short. The one on what we now call dark energy was longer. Some of them are quite long, but he just is a remarkable man, and he had many thoughts about how his science and his faith did or didn't work together.
So let's work up to that. So first, if you could set the stage a little bit about what did people think the cosmos looked like when he was starting? Because to appreciate the change he made, it was
right.
So drastic.
So about 10 years before he started working, which would have been when Einstein published his theory, it was more or less still accepted that the universe was unmoving, was eternal. There was a big debate about whether the sort of smudgy things that you could see in telescopes in between some of the stars were simply little clouds in our galaxy, or whether they were galaxies unto themselves a great distance away from our galaxy. And it wasn't until these big telescopes began to be put into operation, which was really in the decade of the 19-teens, that observations could begin to be made that revealed that, for example, the Andromeda Nebula was actually the Andromeda Galaxy, and it was millions of light years from our galaxy.
So the first unsettling thing is we go from a universe that's much smaller,
It's just
just
our
the size of
galaxy,
the Milky Way.
right.
That was the universe.
Right. So
And now-
suddenly there are all of these others. That
Many,
was
many
one
orders of
thing.
magnitude bigger.
And then the next one was, once you could measure these individual galaxies, you could measure the light from them and see that that light was shifted to the red, which is an indication that they're moving away from us. And that the farther away a galaxy was, based on how much dimmer, and for spiral galaxies, smaller they were, the faster they were moving away. There was that linear relationship, which actually LeMaitre, in working on his PhD, worked with some of those data, but he was not an observer. It was people like Edwin Hubble and Vesto Slipher and others who made those measurements. Now, LeMaitre understood what that meant because he was working on a model of the geometry of the universe in which space itself is expanding. So he knew that that meant that galaxies were not moving away from us through a fixed volume of space, but space itself is expanding, much the way that the surface of a balloon, if you begin to blow the balloon up and that surface represents three-dimensional space, that surface expands in size and everything moves away from everything else. Interestingly, Hubble never accepted that. Hubble is credited with that law, but he's interviewed in the 1940s in the LA Times as saying the universe is not exploding, it's nice and peaceful and static.
So he was a steady state.
He was a steady state guy.
And yet the law was named after him.
The law was
provides
named after him, exactly.
Yeah. So there's
yes, it was very ironic.
Can you say something about the young LeMaitre? I guess this is the young one right here. This is probably a picture from early on.
Yeah, this is from the 1930s.
One of the astonishing things to me is like he chose first to go towards the priesthood, to go to seminary and get ordained.
Yep.
And then more or less, it sounds like in his spare time is working on relativistic math. Is that?
Yeah. So he, when he became a priest, he was also very interested initially in mathematics. And so he did a master's in math in Belgium. But then he, came to read Einstein's papers, the papers of some others, and he wanted to go study and do work on general relativity. So he obtained permission from his superiors to travel abroad, went to the UK, went to work briefly with Eddington, and then he went to Cambridge, Massachusetts to work at
Harvard.
MIT and Harvard.
Yeah.
Yeah, so he was actually at Harvard, but they didn't offer a PhD at Harvard. And so he had to get his PhD at MIT. So,
Well, Harvard's a little behind.
it's always behind.
There's no PhDs
Yeah.
there. What's striking is at that time, am I right in thinking like hardly anybody understood the Einstein field equations in
Right.
deep
So
ways?
so there was just really, you could count the number of people on your two hands.
So
basically.
if you want, there's this apocryphal story that Eddington, I don't know if it's apocryphal or not, but Eddington's story was like, somebody asked him like, oh, you're one of the three people who understand this. And he's like, quite a while, he's like, I can't think of the third person.
Yeah, right.
Because it was Einstein, Eddington, like, well,
Yeah,
that's exactly. But
Yeah.
but of all people, there's like maybe 20, or I don't know, 20, 30
So
people.
there was
that goes to the field.
Alexander Friedman. He
Yeah.
he died early. There was Wilhelm de Sitter, and he was somewhat around a little old. He was older than Einstein. There was LeMaitre, there was Eddington, and then in the next decade there was Robertson and Walker, and that was kind of it.
How does a Catholic seminarian end up on that list? And like when really he's focused on becoming a priest?
Well, I think he was focused. So he knew, as you say, he knew he was going to be a priest early on. That was in his mind. He knew that from when I think he was a teenager. He said that he knew he was going to do that. He served in World War II in the infantry, and then after that he became a priest. But this was his abiding passion, was to understand the nature of the universe. And it was more than solving Einstein's equations, because he then went on to think about the implications of what it meant for a universe to be expanding. If you roll the tape backwards, it isn't just that it's getting smaller and smaller. His solutions allowed for that to be a sort of a mathematically infinite process. But he thought, no, that can't be right. Entropy is going to be decreasing as you go back in time. It can't go to zero. You have to get to a point where everything is incredibly compressed into one primeval atom, as he called it. And he decided the universe had to have a beginning. And he was always careful, because he did have some Thomistic education in his priesthood, not to say that was the creation of the universe. That was the beginning of the universe, as we understand it. Yeah. The creation is something, as he said, it goes on ex nihilo.
And so beginning being like part of the causal order that physics describes,
right?
You can have beginnings there.
Right.
Creation, metaphysical concept, not necessarily
the ontological creation of everything in the eternal now.
And it's striking how sophisticated LeMaitre is, even in these few cryptic remarks you point out. But it makes sense if he was well schooled. He's a priest who knows the truth very well.
In fact, I will, if I can. So I'll read a quote on this issue from him. So he says, with regard to his Big Bang, we may speak of this event as of a beginning. I do not say a creation. Physically, it's a beginning in the sense that if something happened before, it has no observable influence on the behavior of our universe, as any feature of matter before this beginning, the Big Bang, has been completely lost by the extreme contraction at the theoretical zero. Any pre-existence of the universe has a metaphysical character. Physically, everything happens as if the theoretical zero was really a beginning. The question if it was really a beginning or rather a creation, something started from nothing, ex nihilo, is a philosophical question which cannot be settled by physical or astronomical considerations. So he draws a very big, bright line between what astronomy and physics can tell us and what metaphysics and faith have to tell us about why there is something rather than nothing.
So did you see like a theological significance in sort of the hiddenness of God with physics, like getting you so far, but not?
Yeah, this was the other thing. He was really very much into the idea of the hidden God. And there are a couple of quotes here. One of them comes from the last paragraph of his letter in Nature, a paragraph that was never actually published because it appears in an early draft. And that draft shows that paragraph crossed out with a pencil. And what he actually submitted to Nature didn't have the last paragraph in it. So I'll read you the last paragraph. Remember, this was a scientific paper to a scientific journal, so you can understand why he crossed out the last paragraph. I think that everyone who believes in a supreme being supporting every being and every action believes also that God is essentially hidden and may be glad to see how present physics provides a veil hiding the creation. And so this was his philosophical musing, which is on an early version of the manuscript, but didn't then appear. And he talks again about the hidden God in one other place. So he talks about the Christian seeker knows that everything that has been done by God, but he knows also that God does not supplant his creation. The omnipresent divine activity is essentially hidden everywhere. It can never be a question of reducing the supreme being to the rank of a scientific hypothesis. And so everything and anything that is here and was and will be is because of the creator. But the creator doesn't supplant the physics or toy around with the physics or tear a hole in the physics. the physics is the work of the hidden God. Yeah.
Well, it's probably worth getting a little bit into the story of how he failed to get credit, because there was a great mystery, and you point out
Right.
it was revealed relatively recently in some like historical work. What really
about
went
10
on?
years ago now. Right. So, all right. So LeMaitre solves Einstein's field equations with what's called a metric, which is instructions for measuring lines in space that allows for an expanding universe. He publishes in the Annals of the Scientific Society of Brussels. No one pays attention except people who happen to subscribe to that, which was no one. And so Eddington, so this was 1927. 1929.
I want to say who Eddington is. We've talked about.
Yeah, okay, so I'll get to him. Okay, so that was 1927. Arthur Eddington was a prominent astronomer and a devout Quaker at Cambridge in the UK, and a very, very famous astronomer who organized a scientific expedition to test out Einstein's theory of relativity by observing a solar eclipse. And when the moon is covering the sun, you can see the stars very close in the background to the sun. And you can actually measure the shift in the position of those stars due simply to the bending of light by the gravity of the sun, which occurs in Newtonian physics, but it occurs to a different extent in general relativity. And so those bending angles were measured and they conform to the prediction of general relativity. So Eddington was famous for that, but he was also one of these people who knew how to solve the equations. So, okay, 27, LeMaitre publishes in French. 29, Hubble publishes his observations, gets credit for the law. Late 1929, 1930, Eddington gives a talk in which he presents his grand new solution to Einstein's field equations, which corresponded exactly to what LeMaitre had done in 1927. LeMaitre wasn't there, but a colleague, I think a former student of LeMaitre's, was there, and he alerted LeMaitre, so he wouldn't have been a former student because LeMaitre was just starting a professorship, so he would have been a colleague. But anyway, he warns LeMaitre. LeMaitre writes to Eddington, who had sponsored him for a year before he started his PhD. So this is after LeMaitre's PhD, but Eddington is still, for those of you who've done PhDs, you know your father or mother figures are still your father and mother figures. So he respectfully writes to Eddington and says, "Dear Professor Eddington, I wanted to remind you that I published this solution to the equations in 1927, and I presented you with a copy of the paper at the time." Eddington realized that that was correct, that he had forgotten this, and to his credit, he immediately arranged for LeMaitre's French paper to be translated into English and published in an English language journal so astronomers would read it. Okay, so it is now published in 1931 or 1930 in the monthly notices of the Royal Astronomical Society in the UK. And the key paragraph where LeMaitre shows that his metric for space implies what we call the Hubble Law, this relationship between the recession speed of galaxies and their distance, that paragraph is missing from the English translation. And so there's no possibility for him to get credit based on the English language version because it's just not there. So for decades, people speculated, well, did Hubble have it in for LeMaitre and arrange for this to be removed before the publication? In about 10 years ago, Mario Livio, who's an astronomer at Space Telescope Science Institute, became interested in this problem again because LeMaitre, after being forgotten in the 50s and 60s, he died in the mid 60s, kind of came back into vogue a little bit. So Livio went through the archives of the Royal Astronomical Society, and he found the cover letter that went with the English translation of LeMaitre's French paper, the cover letter to the editor of the monthly notices, whose last name, believe it or not, was Smart. Not related to Maxwell Smart, the TV Smart. And that letter was written by LeMaitre, and LeMaitre, in fact, in that letter says, here's the translation. I did the translation myself. And by the way, I omitted the paragraph on the recession velocities of the galaxies, which is no longer of current interest. Yours sincerely, George LeMaitre. Now, why would he do that? He did that because By the time it was 1930, Hubble had published a much larger data set of these recession velocities. And what LeMaitre had used in 1927 was a much smaller data set that gave a rattier answer. Now, remember, it's a linear relationship, so you're fitting a straight line between the recession speed and the distance. You look at LeMaitre's in his original paper, and it's sort of all over the place, but he knew it had to be right because it came out of his metric. So Hubble had much better data, and LeMaitre didn't see any reason to publish ratty data that was out of date. Now, he did come to regret that later. He realized what he had given up. He was not exactly a saint, but he did at the time do the honest scientific thing, which was, don't publish data that's kind of out of date. And so that's why he didn't get credit for it at the time.
Yeah, and what it might be worth mentioning, he's not a saint necessarily, but it was out of humility in some level.
It was sort of, yeah.
Well,
So
there's better data.
He was a curious person because he would do things that seemed like they were really the epitome of humility, which, as we know, for those of you who work in the sciences, that is not a particular attribute that is in great supply. And then he would do things that suggested he wasn't all that humble either. Right. So, for example, in the the early 1950s, when Pope Pius XII, I believe it was, gave his famous Fiat Lux speech to the Pontifical Academy of Sciences, in which by that time the Big Bang model was well known. It was being opposed by a steady state model. So the Holy Father gave a talk in which he said that this work had demonstrated, in fact, that the book of Genesis was correct, essentially. It was a much more reasoned argument than that, but that was how it sort of appeared. Yeah. LeMaitre was there in the audience, and he came back really steamed. Now, was he really steamed because the Holy Father had basically conflated his physical model with the book of Genesis? That was part of it. But the other part, according to LeMaitre's students at the time, was that the Pope did not recognize by name LeMaitre in the audience, who was the author of this great model. So, he was a human being. He had two sides to him. There's no question that in terms of being, very honest and entirely ethical about his work, he really, really was. There's no doubt about that. But he still had a little bit of an ego, I think.
Now, but that brings up an interesting and kind of a deep methodological question here. Right. He gets accused of being just motivated by his religious beliefs.
He did.
To drive his science.
Yes.
Which is, in some ways, a really sharp accusation.
Right.
And the Pope sure didn't help things any, I guess.
No. So this came along just 3 years after Fred Hoyle, Tommy Gold, and Herman Bondi published 2 papers in which they presented a model of the universe completely in opposition to the Big Bang model. It was called the steady state model, and it postulated that the universe had infinite age and was unchanging. It always looked the way it looks today. Now, how can you do that if space is expanding? Well, what they postulated was that matter was being continually created to replace the dilution of matter as space expanded. And that's an arbitrary assumption, but it only requires adding a few hydrogen atoms per cubic parsec per billion years. It's some very small number. Hoyle accused LeMaitre of, and actually didn't accuse him directly, but what Hoyle said, and Fred Hoyle was very flamboyant. He had his own radio show on the BBC, a very famous astrophysicist, also an atheist. But what he said was that scientists liked the Big Bang model because it conformed to the book of Genesis, and that scientists had the book of Genesis in their minds and therefore were essentially prejudiced in favor of that model. And he later admitted that one of the reasons they came up with the steady state model was just simply to counter the Big Bang model.
Which is extraordinary because the normal criteria of scientific theory choice, when philosophers and scientists talk about this stuff, the idea of adding a bunch of junk to be able to like get your preferred answer, that looks more like motivated, like, so if anything, that is like a huge amount of projection going on. It's like, it looks like the atheist in this case, Hoyle, was deliberately contorting stuff to like get the answer sort of right.
There was
As opposed to,
right. There's a lot of prejudice, but it's also the case that there's a natural repulsion, I think, in physics and astronomy to the idea of having a starting point, a finite age of the universe. Now, today we don't worry so much about that, but there are models in which, for example, the Big Bang is just one of many cycles. There are models in which our universe, the Big Bang is just the budding off from some underlying sea of quantum reality, where there are innumerable other universes that are budding off, and so we're just one event in that. Physicists don't like the idea of having to deal with a time when there just wasn't anything, and there's a natural tendency to try to do a different kind of model. Steady state model was disproved in the 1960s when two radio engineers from Bell Labs detected this ubiquitous cosmic static that permeates everything. It's actually the echo of the moment in the expansion of the universe when matter becomes dilute enough, the universe cools down enough that light and matter can separate from each other, and light is now free to move through space. And that moment, which is at a very high temperature, is redshifted way off to the radio part of the spectrum. Once that was discovered, the steady state people threw their cards on the table. They said, we fold, this isn't predicted by our model, and that was gone. Steady state model was gone, to their credit. LeMaitre was told of this discovery literally in the days before he died of leukemia. So he just learned about it before he died. So that the Big Bang model became the reigning model. Astronomers have to reckon with it today.
Yeah. We have a question, let's see, one from, I believe, the Zoom here from Stephen. Can you expand a little on LeMaître's concept of God not supplanting the creation, and if he discussed how that might interact with the idea of the miraculous?
So God, it's not that God doesn't supplant the creation. God is the creator of creation. I mean, all of reality is the result of this creation from nothing. What LeMaître's point is that one should not confuse the Big Bang, the beginning of the history of the universe that we can trace with our physics. One should not confuse that with the creation, because the creation, as you and I just talked about, has to do with the ontological bringing into being of everything. And that's a timeless act. It's not something that happens at a moment in history. In fact, LeMaitre in another quote talks about this concept of which was very popular in the 19th century and 18th century, when everything was thought to be completely mechanistic and deterministic, of God sort of lighting a piece of paper and setting the universe off and everything going from that point on. That's not his picture of creation.
Mike was saying something about that. The picture of creation, because that's a really common idea. It's like, oh, well, God sets up the physics and then like work is done. Like,
Stephen Hawking says, light's the blue flash paper that gets it going, and that is not. It's certainly not a Thomistic point of view, for sure.
Yeah.
And it's not LeMaître's point of view.
And fair, not just Thomistic. I mean, the entire tradition, like going back.
Fair enough. Yeah, that's right.
Concurrence and all this stuff. That you have some quotes from.
I'm just trying to see. So what was the second part of the question?
How that might interact with the idea of the miraculous.
Yeah. So LeMaître's view of the miraculous, of course, LeMaitre was firm in his faith about the incarnation, the resurrection of Jesus. All of these things were things that were part of God's plan for salvation. And in fact, I'll read a little bit on that in a moment. There are some miracles that he actually didn't accept. For example, the miracle at the Fatima miracle, for example, with the moving of the sun. He had some critical things to say about that. So there's not a lot on that issue, but he clearly is. So he's clearly not a materialist in the sense of simply dismissing everything that's a miracle, the miracles of Jesus, the healing miracles, the other miracles, the raising of Lazarus. Those are things that he absolutely accepted as true and part of the faith. But there were other more recent ones that he tended not to say much about. Now, what about miracles and physics? Well, miracles are things that happen because of God's direct intention to do those things. God is both transcendent and also immanent. And of course, as for those of us who are Christians, we believe in a personal God who does intervene, but only intervenes for reasons, not for, not arbitrarily or capriciously. And so the creator of the physical laws and the reality around us is, of course, free at whatever time to do something that might seem to be in contravention of those physical laws, although most miracles are not necessarily violations of physical law. You read them and you say, okay, this might have happened because of whatever.
Yeah.
I don't like going down that road, but I will just point out there is a book by a fundamentalist Christian, Frank Tipler, who's a physicist, who actually worked on the anthropic model of the universe. Yeah, exactly. Called The Physics of Christianity, in which he attempts to explain every major miracle in the New Testament in terms of physics. In the end, you sort of scratch your head and say, why did he bother doing that? But I think his point was, you don't have to say that miracles are a straight out violation of physical laws. They're a manipulation of the causality of things, which is a different statement. And there are reasons for them that have to do with human salvation.
God is the option.
God is the option, exactly.
Doing things within his rules.
Right.
We have a question. I'm not sure if it's in the room. Is Fonzie in the room? And if not, I'm going to read the question out. Is there any evidence that LeMaitre connected his thoughts on the hidden God with Martin Luther's theology of the cross? I'm going to venture as a Catholic, probably not.
I'm not aware of that.
Yeah.
That's right.
Although the theology of the cross more generally and the hidden God, there might be an interesting connection. So one of the things about divine hiddenness, which would be kind of interesting to know what LeMaitre thought of this, is like there may be very deliberate reasons God has for that are mercifully hiding his self, full self from being revealed at any given moment, because I probably couldn't take it. You and I couldn't take if God was really revealed right here in this room.
Right. I mean,
a little bit of trouble.
The direct vision of God we would not be able to handle in our physical state. Exactly.
And then, do you think like LeMaitre had an understanding of physical reality being a kind of mediated way of God's pursuing a union with creatures in a way that's not going to annihilate them?
He did actually, but in a slightly different way. He addressed. In his view, the human mind, in fact, is capable of understanding the nature of the cosmos, which is God's creation, because not only is that what God intended, but because it is an expression of God's love to be able not only to comprehend the cosmos, but to appreciate, to be able to do so through science. So I'll give two quotes on this idea. The first is that when he accepted the Franck Prize, which he was nominated by Albert Einstein at the time, it was the second most lucrative prize after the Nobel Prize. He said in his acceptance speech, "Science is beautiful. It deserves to be loved for itself, as it is a reflection of God's creative thought." And then as far as the comprehensibility of the cosmos, he said in response to Einstein's posing the question, the eternal mystery of the world being its comprehensibility. How can we understand the world? Why should we be able to understand the world? LeMaitre said in 1936, both of them, the scientist believer and the scientist non-believer, attempted decoding the palimpsest of nature. The palimpsest is the sort of clues left behind about the nature of things. Both of them attempted decoding the palimpsest of nature. The believer perhaps has an advantage of knowing that the riddle possesses a solution, that its degree of difficulty is presumably measurable with the present and future capacities of humanity. And he elaborates a little bit more on that elsewhere, where he says it's the intention of the creator that his creation should be able to understand the majesty of the cosmos, and science is the way that we do that.
Yeah.
So I think that sort of plays into this question of the hidden God. We don't see and we cannot see God in the full glory of the Godhead. Of course, we experience and have experienced Jesus Christ on earth, but we can experience the creation, which is this reflection of God's thought. It is God's thought.
Yeah. Another question coming up. Let's see. Alex, are you in the room? Is it one of the Alexes? Here we go. Alex, yeah, go ahead.
Yeah, I was wondering if you had any advice for young Christians in science who are trying to navigate this overwhelmingly anti-religious attitude in the scientific community. You mentioned that there was an element of prejudice in LeMaître's story. So
right, so it is very difficult, and you see that in your professors and fellow students. I think it varies from department to department and field to field. I think it's less of an issue in physics and astronomy than it is in biology, for example. So my first piece of advice is, whatever denomination or Christian faith you belong to, be sure to, go to church and join a youth group and participate in that, because that's a really important and reinforcing outlet for you. Number two is do your science the best you can, because the best demonstration that faith, whether one has faith is not a measure of one's ability to do science, is to do science as well as possible, to be the best scientist you can possibly be. And then just ignore people's opinions, because, I've sort of, I don't want to pull the age card on you, but the older you get, the more you realize that most people's opinions most of the time really aren't worth paying a lot of attention to. I mean, if someone says that a crane is about to collapse on top of you, that's a good thing to take some advice on and run away from. But, someone's particular view on your religious faith is really not, in the end, all that interesting. Sadly, we do counsel young faculty who are believers, who are, on tenure track, to kind of keep that sort of low key, because sometimes tenure decisions get made on the basis of things that are really not relevant. But that does happen, and less so for students in passing your PhDs, I have to say. I'm very proud of my own department of the openness that people have, and in fact, Saul Tucholsky, who's not a believer, his most recent graduate student, Dante Yotza, went on to pursue the priesthood as a Dominican, and it was very interesting listening to Saul trying to introduce Dante at the beginning of his thesis defense. He was trying to describe it in a way that he thought would not alarm people that he thought might be alarmed if he said he's joining the priesthood. And so it turned out to be this sort of alphabet soup of euphemisms, but it was all in a very kindly way. So anyway, that's sort of long-winded, but church, be the best scientist you can be, and just ignore people's irrelevant opinions.
thank you.
Yep.
We have a question from Joe Dill, who's actually on Zoom, so I'm gonna have to ask for him. It's too bad, but Joe is actually a physics graduate student as well. How did LeMaitre and / the Thomistic tradition think about the interpretation of Genesis chapter 1?
Yeah, so LeMaitre had a lot to say on this, and I'll read a couple of things here. So I don't have both quotes, but in one quote, he makes it clear that the Bible is not intended to be a science textbook, and the Bible is intended to teach us what we need for our salvation. And so, he was straight out saying that people who wrote the Bible, who were inspired by God's hand, if you want to think of it that way, were no more knowledgeable about the physical world around them than anyone else was at that point in time. And so he just said, there are things in the Bible that are not scientifically, factually correct, but that are teaching other kinds of deeper lessons about human salvation. And of course, this is a tradition that goes back in our Christian faith to St. Augustine, who wrote an entire treatise on the literal interpretation of Genesis. and cautioned Christians not to give too facile an interpretation to Genesis, lest they embarrass themselves in front of non-believers. And so, the tradition of interpreting Genesis literally in sort of opposition to whatever the scientific worldview at the time is really kind of a fairly recent, recent in the sense of the Reformation, and then the Counter-Reformation is where that began to come up. But prior to that, the Christian fathers many of them didn't interpret it literally in terms of the length of the days and so forth.
Yeah.
So I'll read one thing then on this, which is from LeMaitre himself. And so he's talking about the fact that the Bible will not have in it scientific insights that came about later. Should a priest reject relativity because it contains no authoritative exposition on the doctrine of the Trinity, sort of inverted things? Once you realize that the Bible does not purport to be a textbook of science, the old controversy between religion and science vanishes. The doctrine of the Trinity is much more abstruse than anything in relativity or quantum mechanics. But being necessary for salvation, the doctrine is stated in the Bible. If the theory of relativity had also been necessary for salvation, it would have been revealed to St. Paul or to Moses. As a matter of fact, neither St. Paul nor Moses had the slightest idea of relativity. So that was his view. The other thing I would say when people focus on Genesis is I always like to say, by all means read Genesis, but don't ignore the prologue to the Gospel of John, which I think has a much more profound expression of what it means for us to be a created being, and that in the beginning was the Word, and the Word was God, and the Word was with God, and nothing was created without that Word, that the universe has a wisdom imbued in it that is there because it was created by this omnipotent being. So, there are lots of creation stories in the Bible. Don't forget the prologue to the Gospel of John. Don't forget the Book of Wisdom, which in the Catholic Bible is a canonical book, the Wisdom of Solomon. There are lots of things in there too. Genesis, as my friend Guy Consolmagno likes to say, was written in the context of people who were steeped in Babylonian cosmology during the exile.
Yeah, and probably there's a lot more to say. We actually do get into some of this in other places, but the very least, even with Augustine that you mentioned, genre being a huge part of this is like, how are we taking the text to be intended to be read? What is it intending to be kind of? So even the word literal gets complicated. You're like, well, actually, the literal reading might be very different than what you think when you take into account the authorial intention.
That's right. Reading it as a science textbook is not a literal reading of it. Literal is reading it the way the book was actually intended, which is what Augustine meant by the title of his treatise.
Complicated questions. It doesn't leave it settled, but at least it makes it opens up some possibilities. We have a question here. You mentioned that LeMaitre dealt briefly with quantum mechanics. Did he have any views in its probabilistic nature?
He did. He had, so he attempted to incorporate quantum mechanics into general relativity. It didn't really work because he was not well enough steeped in quantum mechanics, but he did think about the question of what would happen right at the beginning if you only had a single, what he called a single quantum, the primeval atom, and how that would split apart. He never really made much progress in quantum mechanics, but he really embraced it in a way that Einstein never did. And in fact, I have a quote here on the indeterminacy of the universe, which I think is a very important thing to recognize, because the fact that the universe has an indeterminate aspect to it does not imply that that God is not omnipotent in some way. That indeterminacy is baked into the nature of the universe that God created, and I think, in fact, is really necessary for us to have free will. In fact, a universe that is regular and ordered and has an indeterminate aspect is pretty much what you would expect to have if you would want to have a universe where creatures have free will. So I will read just briefly. Okay, so LeMaitre says, in Laplacian determinism, everything is written Evolution is similar to the implacable rotation of a recorded magnetic tape or the engraved spiral of a phonograph disc. Everything that would be heard would have been read from the tape or the disc. It is quite another story with the advent of modern physics. And according to the present theory, these concepts should also apply to the universe, at least the beginning of its evolution. The beginning is perfectly simple, indivisible, indifferentiable, atomic in the Greek sense of the word. The world differentiates as it evolves. It does not consist in the spinning out, the decoding of a recording. Rather, it consists in a song, each note of which is new and unpredictable. The world made itself and made itself randomly, but made in the sense of evolving, not in the sense of creating from nothing. Yep.
Yeah. So yeah, let's say there the complexity of indeterminacy and free will, unfortunately, is like way more than we can get to in the last like 5 minutes.
Oh no.
But, because one of the problems is indeterminacy doesn't seem suitable on its own for free
Right.
will, just on its own. But it is like a question of like, well, how would this work?
Yeah.
And then it's gonna.
So I know you want to take questions. I know we only have 5 minutes. I want to read two
Go ahead.
quotes.
Go ahead.
I want to read one from LeMaitre and one from another hero of mine, the Anglican priest who passed away last year, John Polkinghorne.
And also a physicist.
Also a physicist, a particle physicist, participated in the development of the Standard Model. Later in his life, figured he had done enough in particle physics. It was time to become a priest. This is a great book, Quantum Physics and Theology. I really recommend it. So I'm going to read, has to do with science and faith. So first, LeMaitre. There are two ways of arriving at the truth. I decided to follow them both. Nothing in my working life, nothing I've ever learned in my studies of either religion or science has caused me to change that opinion. I have no conflict to reconcile. Science has not shaken my faith in religion, and religion has never caused me to question the conclusions I reached by scientific methods. And that's consistent with John Paul II's faith and reason being in harmony with each other. Polkinghorne says the same thing in this book. He says, people sometimes think that it is odd or even disingenuous for a person to be both a physicist and a priest. It induces in them the same sort of quizzical surprise that would greet the claim to be a vegetarian butcher. Yet to someone like myself, who is both a scientist and a Christian, it seems to be a natural and harmonious combination. The basic reason is simply that science and theology are both concerned with the search for truth. In consequence, they complement each other rather than contrast each other. He goes on, but I'll stop there. So something to really bear in mind.
Yeah. We have a question here. As an accomplished scientist, this is addressed to you, what core motivations, dispositions, and fear do you encounter most when dialoguing within the church, like within Christian circles, about cosmology?
I guess I haven't had any fear. So I'm very blessed to have had associations with first the Vatican Astronomers.
Might want to say a
I
little
will
bit
say a
about
little
that.
bit in
'Cause I
just
think
in
that's an
30
extraordinary
seconds.
story.
So unrelated to LeMaitre, because he was not a Jesuit, the Vatican has had an astronomy group, which for most of its history has been populated with Jesuit friars, brothers, and priests as well. And they do scientific research, and they have made a number of very important contributions to the history of astronomy. They still do that work today. And they, even though they have a religious life, they are free to do their work exactly as secular scientists do. And two of them have won awards from the American Astronomical Society. One of them was the chair of the Division of Planetary Science, which is the professional organization that I belong to, even though he's Jesuit brother. So dialoguing with them, dialoguing with colleagues in the Society of Catholic Scientists. We have meetings every year. We have fun talking about cosmology. I've never really run into a kind of a dialogue or discussion where that has produced any fear. I know fear was used in that question. Now, people may disagree and say, the universe is just because it is. There is no creator, and it's just a brute fact. Well, that's okay. Let's have a discussion about it.
Well, could I ask you to say maybe a little short version of how you encountered the Vatican Astronomers? Is a very special way for you in your life.
Oh yeah, so I taught at the University of Arizona before I came here. I arrived in
26 years.
26 years. I was at the University of Arizona. So I arrived a year after my my PhD, or I became a professor a year after my PhD. I had known Guy Consolmagno, who was just joining the Vatican Astronomers. He was just becoming a Jesuit brother. He had been a planetary scientist too, like me, and was a couple of years ahead of me. Anyway, he invited me to a dinner of the Vatican Astronomy Group. Although their headquarters is in Rome, they have a Western headquarters at the University of Arizona, because they have a telescope that at the time they were building in the mountains there.
Just for the sake of the story, we should know, like, how did you identify at that time? Like, where was your religious identification?
I was Jewish.
Okay.
And I wasn't really practicing.
Okay.
Actually, I got married a year later to a Methodist, and we went to a wonderful Methodist church for 20 some odd years. A fantastic pastor, David Wilkinson, incredibly gifted, steeped in Pierre Teilhard de Chardin and Augustine and others. Brilliant, brilliant man. Learned a lot from him, learned a lot from the Jesuit astronomers, that science and faith really were two harmonious parts of the human person, that you could be a scientist and be a faithful religious person in a harmonious way. That was a really important lesson. And years later, when I converted to Catholicism, part of what influenced me was seeing how those men actually lived their lives. And, you know, existence proofs are always important for scientists. And that was an important one for me.
Just to be able to see. And it led to you, in your own case, is that right? To you actually encountering the Catholic Church in a way that led to your...
Well, so God worked in many different ways. I had a spiritual experience when I was a teenager. I put it aside. Jesus Christ came to me in a dream, but it was really more than just a dream, but it would take too long to explain it here. There were the 2 decades of listening to David Wilkinson's sermons. There were the Vatican Astronomers. There were, and so all these things, plus going to Rome and visiting the churches. Now, I spent in the last probably 5 years before I converted thinking a lot about these things, and finally at the age of 47 decided it was time to actually do something.
And then maybe to close out, what would you say, like, what you see the kind of lasting, the thing we should take away from LeMaître's example, or what you can see the most valuable lesson?
Well, so first and foremost, the most valuable lesson is that the idea that science and faith are in conflict with each other, and one can't honestly be a believer and be not only a scientist, but an extraordinary scientist, is simply false. And if people, you hear people saying, well, there's always exceptions to the rule, he was just a freak. Well, then there's Polkenhorn. Well, if you don't believe Polkenhorn, then there are the Vatican Astronomers. You don't believe them, there's Father Nicanor Austriaco, who's a Dominican priest and a biologist. And so it just goes on and on. But he is sort of the epitome of someone who was both a brilliant scientist and deeply involved in the life of the church. And so that is the important takeaway there. The other important lesson I take from LeMaitre is Stigler's law of eponymy, which is a law that says that no discovery is actually named after his discoverer. And Stigler admits that.
Isn't that true of Stigler's law too?
It is,
yeah.
It was named after discovery. He admits that too. Yeah,
the ultimate confirmation law.
Yeah,
he didn't even know.
And so, we should pursue our science, not expecting that we're going to get a sort of a one-to-one reward. The reward is doing the science and having the pleasure of working with colleagues, of perhaps making a discovery or two. That's really the important thing. It's not the credit or the fame or anything like that. I mean, LeMaître's statement that science is beautiful is, I think that, this should be put on every scientist's wall, at least every scientist who is a believer, that science is beautiful. It deserves to be loved for itself, as it is a reflection of God's creative thought. And that is the way that LeMaitre lived his life.
All right, well, that's a fitting place to end our conversation. Thank you so much, Jonathan, for joining us.
Welcome. Sure.
I want to say a special thanks to our audience, both here and on Zoom. This is our last public event, I believe, of the year. So it's been quite a year. We've had a lot of stuff happening, and the people who make that happen are our ground team staff. And I want to say a special shout out for all of you who get to enjoy this. there's a lot of work that they put into making these events happen. So thank you to the Chester House ground team staff for making everything, all of these come out so well. And one last thank you, I want to say for our supporters. Some of you are on this call. I want to say thank you so much for keeping this ministry, this faithful Christian presence, basically sustained and alive here on Cornell. And we are so glad to be kind of partnering with you to do ministry work in a context that's not often associated, just like LeMaitre. You don't often think of ministry work happening at kind of high academic settings, and yet this is exactly where we were called to be. So thank you for joining us. Thank you for supporting us. And we look forward to seeing you online in another way. So appreciate it. Have a good night, everybody. We'll see you.